Hello, and welcome to the short video from Semantic Designs on our automated COBOL migration capability. I'm Randall Mathias, Business Development Manager, and I'm joined by Dr. Richard Cohen, Senior Migration Engineer. Before we begin, I'd like to provide you a brief introduction to Semantic Designs. Founded in 1996, our business is automating large-scale software analysis and change. We do this using a proprietary generalized compiler technology called DMS. With DMS, we're able to perform many different types of projects, including technology migration, converting one application set of technologies to another, code refactoring and re-architecture, as well as build custom analysis tools. We've also used DMS for many different technologies. To date, we've used DMS on over 40 different programming languages. And we're very proud of the fact that in our 25-year history, we've never failed to deliver on a customer engagement. When it comes to automated code migration, Semantic Designs is unique in several aspects. First off, we de-risk the project by adhering to a proven methodology that begins with an assessment phase. During the assessment, we use tools to ensure that we accurately understand all the elements of the customer's legacy application ecosystem, including what features of COBOL they use, what's used for databases, are there APIs to other applications, and so forth. We then work closely with the client to understand their preferences for the target architecture. Because we have tremendous flexibility with DMS to be customized and configured based on the client's specific choices, we don't dictate a target set of technologies to the customer. Instead, we work closely with them so they can choose what they want for each aspect of the application ecosystem in the new environment. This flexibility means we can customize the translator based on a specific set of goals of the client. Through this, we're able to achieve very high levels of automated conversion, often hitting nearly 100% of the code being converted in automated fashion. Lastly, and most importantly, this flexibility to customize and configure DMS means we can produce very good quality, highly maintainable code. The iterative process allows our customers to provide feedback on the generated code. Semantic Designs can then take that into account and modify the translator based on the feedback and regenerate the code. This iterative process allows our customers to provide feedback on the generated code. Semantic Designs can then take that feedback into account, modify the translation rules based on the feedback, and regenerate code. Through this process, we continually improve the translation until everyone is satisfied with the code being generated. This also means no code freeze. The customer continue maintaining the application throughout the project, and only when we're ready to do the final translation of a particular set of code is a code freeze needed. Now I'm going to turn the presentation over to Rich Cohen, who's going to show you a demonstration of the translator. Rich?
I'm going to demonstrate our COBOL2CSharp translator. For this demo, we're targeting C#, but we could just as easily target Java. We'll use this small COBOL program to illustrate some features of the translator. This small example performs some COBOL arithmetic, and we will see the translator preserves the precise COBOL computation in the generated C#. This program mimics part of an order processing application processing one line item, which has a quantity and a price. It will multiply the quantity by the price to get the gross amount, and then if the gross amount exceeds some threshold, it will apply a discount. We'll look at the computations more closely after we've done the translation. I'll run the COBOL2CSharp translator using a project file that I've already prepared. The translator has a number of runtime configuration options, and the translator options are being reported here, the options used for this particular run. At the end of the conversion, we see that 100% of the code was converted, which is what we like to see. We can take a look at the generated C# code and compare it to the original COBOL. Let's look at a few key observations. The COBOL data item total amount has been declared as a numeric field with 2 digits to the right of the decimal point. This has been translated into a C# decimal native type. A decimal field in C# can do precise arithmetic computations with digits to the right of the decimal point. If we look at the data item discount percent, we will see that it is declared pic99. This has been translated into C# as an S byte because a C# S byte can hold any 2-digit numeric value. Now let's look briefly at the procedure division. The procedure division first performs paragraphs compute total through compute discount, and then paragraph display total. If we look at the corresponding C# in the main procedure, we see a call to compute total, and then a call to display total. The translator has performed a control flow analysis and noted that the first perform statement executes multiple paragraphs. It has formed these paragraphs into a single C# method, which is then used in the translation. If we look at some of the numeric computations, here's a COBOL multiply quantity by price giving gross amount. That translates into a native multiply in the C#. Quite readable. Similarly, the conditional statement, if gross amount is greater than discount threshold, translates into a native numeric computation in C#. The next step in the COBOL is to divide 100 into the discount amount. This is required because the discount percentage was given as an integer, not as a fraction. If we look at the computation in C#, we see the division by 100, but in addition, we see the translator has added a call to truncate, saying to truncate the result to 2 decimal places. This is required because in the COBOL program, discount amount is declared with 2 digits to the right of the decimal point, but the division effectively shifts the amount 2 digits to the right and may have produced a quotient with 4 digits to the right of the decimal point. So the translator explicitly truncates to 2 digits, which is what the COBOL computation would have done. The next line subtracts discount amount from total amount. If we look in the corresponding C#, we see that subtraction, but we also see that it's surrounded by a call to math.abs. That's because the total amount is declared in COBOL as being unsigned. The translator knows that subtraction can produce a result that is less than 0. COBOL would just assign the absolute value of the result to the target, and so the translator has called an explicit call to math.abs to preserve what COBOL did implicitly. We can compile the generated C# by running a small script. This will compile using the C# compiler from Microsoft and then run the resulting compiled code. And we can see that result. And just for fun, we can compile and run the original COBOL version. And when running the COBOL program, we'll see that we get exactly the same output. The total is 113.61 in both cases. This short demo has just illustrated a few features of our COBOL to C# translator, but I hope it's been interesting.
Thank you, Rich. If you'd like more information on how automated migration might benefit your organization, visit our website at semanticdesigns.com and click the Request a Free Migration Consultation button. Thank you. This concludes this video from Semantic Designs.